Hi everyone, Assalamu alaikum wa rahmatullah. My name is Saadullah Karimi. Today I want to present my 10 paper presentation about Introduction to Wireless Sensor Network. This is table of contents I want to go through. Next slides. Introduction. Sensing is a technique used to gather information about physical object or process, including the occurrence of event. For example, the human body equipped with sensors that are able to capture optical information from the environment with eyes, acoustic information such as sounds with ears, and smells with nose. As you see in a diagram, there's example of sensing. Sensor classification. Which sensor should be chosen for an application depends on a physical property to be monitored. For example, such a properties includes temperature, pressure, light, and humidity. Types and example: temperature, pressure gauge, optical, acoustic, mechanical, and extra. Wireless sensor network. Wireless sensor network, while many sensors connected to controllers and processing station directly using local area network, an increasing number of sensors communicate the collected data wirelessly to centralized processing station. This is important since many network applications require hundreds or thousands of sensor nodes, often deployed in remote and inaccessible areas. Therefore, wireless sensor has not only sensing components, but also on-board processing communication and storage capabilities. With this enhancement, a sensor node is often not only responsible for the data collection. Sensor nodes communicate not only with each other but also with a base station using their wireless radios, allowing them to disseminate their sensor data to remote processing, visualization, analysis, and storage system. For example, as you see in the figure, their every nodes are connected to each other and collect data sent to the nearest node and the base station through the internet go to the storage. History of wireless sensor network. History of wireless sensor network. As with many other technology, the military has been a driving force behind the development of wireless sensor network. For example, in 1978, the Defense Advanced Research Project Agency organized the Distributed Sensor Network workshop, focusing on sensor network research challenges such as networking technology, signal processing techniques, and distributed algorithm. Also operate the Distributed Sensor Network program in early 1980, which was then followed by the Sensor Information Technology program. The University of California at Los Angeles proposed the concept of wireless integrated network sensor in 2001. One outcome of the project was the low power wireless integrated microsensors produced in 1996. This smart sensing system was based on CMOS chip, integrating multiple sensors, interface circuits, digital signal processing circuits, wireless radio, and microcontroller onto a signal chip. The Smart Dust project in 1999 at the University of California and Berkeley focused on the design of extremely small sensor node called motors. The goal of the project was to demonstrate that a complete sensor system can be integrated into the tiny device. The Berkeley Wireless Research Center focused on the development of low-power sensor device, whose power consumption is as small that they can power themselves from energy source of operating environment such as solar energy. Okay, as you see in a diagram, a remote deployment of sensor for tactical monitoring of enemy troops movement. Communication of wireless sensor network. The well-known IEEE 802.11 family of standard was introduced in 1997, and the most common wireless networking technology for mobile system is use different frequency band. For example, in 2.4 GHz band, it's used IEEE 802.11b and IEEE 802.11g, while the IEEE 802.11a protocol used the 5 GHz frequency band. IEEE 802.11 was frequently used in early wireless sensor network and can still be found in current network when bandwidth is Uh, okay, when bandwidth is demand are high or multimedia sensor. As you see, multi-hub and single hub. In multi-hub, this parent with child and child send collecting data to parent to the base station. And single hub, there is a single sensor with base station. This is global level and local level, as you see in global level database server and application server. Challenge and constraint. While sensor networks share many similarities with other distributed systems, they are subject to a variety of unique challenges and constraints. These constraints impact on the design of wireless sensor network, leading to protocol and algorithms that differ from their counterparts and other distributed systems. This section describes the most important design of constraints of wireless sensor network. Energy is the main challenge of wireless sensor network. Constraint most often associated with a sensor network design that sensor nodes operate with a limited energy budget. Typically, they are powered through the batteries, which must be either replaced or recharged when discharged. The self-management, and it is the nature of many sensor network applications that they must operate in the remote area and harsh environment without infrastructure support or the possibility for the maintenance and repair. Therefore, sensor nodes must be self-managing, and they configure themselves, operate and collaborate with other nodes, and adopt the failures changing in the environment and change in the environmental stimuli without human interventions. Ad hoc deployment. This is particularly important for network being deployed in a remote or inaccessible area. For example, sensor serving the assessment of battlefield or disaster area could be thrown from airplane over the area of interest, as you see in the preceding diagram, but many sensor nodes may not survive such a drop and may never be able to begin their sensing activities. Unattended operations. Many sensor networks, when deployed, must operate without human interventions. That is, configuration, adoption, maintenance, and repair must be performed in autonomous fashion. Wireless and networking. The relevance of wireless network and communication pose a number of challenges to a sensor network designer. For example, attenuation limits the range of radio signal that our radio frequency signal fades, decrease in power, while propagate through a medium, and while it's passed through obstacles. Relationship between the received power and transmitted power of a signal can be expressed using the inverse square law. Decentralized management. In the large scale and energy constraints of many wireless sensor network make it infeasible to rely on centralized algorithm executed at the base station. They implement network management solutions such as topology management or routing in a state. Sensor node must collaborate with their neighbors to make localized decisions that's without global knowledge. As consequence, the result of this decentralized or distributed algorithm will not be optimal. Design constraint. While the capability of traditional computing systems continue to increase rapidly, the primary goal of wireless sensor design is to create smaller, cheaper, and more efficient devices. Security. Security is the main challenge. Another challenge of wireless sensor network. Many wireless sensor networks collect sensitive information. The remote and unattended operation of sensor nodes increase their exposure. The malicious intrusion and attacks further wireless communication, make it easy for an adversary and eavesdrop on sensor transmission. For example, one of the most challenging security threats is denial of service. Other challenge, we compare traditional network with a wireless network, as you see in a diagram. Okay, thank you for your. Thank you. If you have any question, please ask. Thank you for your attention.